Hi everyone. We are going to just sort of quickly go over some terms. This is a little bit harder to teach because it's really not calculations, it's more just terms, and you just have to keep reviewing those and going over them. And I'm going to try to make a little bit more sense to you, but we're not going to spend a lot of time with this. This is just kind of some basic knowledge behind liquid, and we're going to look at solid states. All right, when you evaporate something, evaporation is the conversion of a liquid into a gas phase. So we've all seen that before, whether it be boiling water or whatnot. And so in order for this to happen, the liquid has to absorb heat in order for it to evaporate. So that's endothermic because it gains heat. And then condensation is the opposite. So a gas cools to the liquid phase. And so this is exothermic because the gas is going to give off heat to the surroundings. All right, the vapor pressure is the pressure that is exerted by gas molecules. This is key here. Gas molecules, okay, in equilibrium with the liquid phase, okay? So vapor pressure is going to go up just like any pressure when you increase the temperature. Okay, so the boiling point of a liquid is when the temperature, when it reaches its vapor pressure, okay, which is equal to 760 millimeters mercury or 1 atm. Okay, so what can be confusing is we've just previously talked about in the previous videos intermolecular forces. Okay, the stronger the intermolecular force, the lower the vapor pressure. Okay, and that is sort of opposite of what students are thinking at this point. Okay, so let me try to explain this to you. If you have strong intermolecular forces, then water in its liquid form, if this is really strong, okay, then those hydrogen bonds, those are the strongest intermolecular interactions, okay, they're holding the water molecules in the liquid phase because this is strong. It doesn't want to break. So the stronger intermolecular forces keep the water molecule as a liquid. So there are fewer gas molecules. So if you look back here, what vapor pressure means is pressure exerted by gas molecules. So if you have a liquid that has very strong interactions, then it has few gas molecules. Therefore, if it has fewer gas molecules, our definition says that it's going to have a lower, it has to be gas molecules to make pressure, right? That's what gases do, they build up pressure. Okay, so if there's not as many, you're going to have a lower vapor pressure. Whereas over here we have methane, which is just a nonpolar, only has London intermolecular forces. Therefore, these are weak interactions holding the methane molecules together. So more of those methane molecules want to go into the gas phase. Okay, therefore it has a higher vapor pressure because you have more gas molecules. Okay, because we're looking at here at a difference between state, between liquid and gas. So if you have stronger interactions, you have less gas molecules because they're staying together in the liquid phase. Here we have more gas molecules because methane has weaker interactions and it wants to become a gas more easily. So you have more gas molecules to make it have a higher vapor pressure. All right, two terms. That's all these next two slides are. If something is viscous, we've probably all heard that before. It means that you're measuring the fluid's resistance to flow. Okay, so a viscous liquid feels thick. So compounds with strong intermolecular forces tend to be more viscous, and this makes sense. So what you would probably think. Okay, and if molecules are larger, they also tend to be more viscous, right? They're not going to flow as freely if they're bigger, okay? So viscous versus surface tension are two different things. Okay, surface tension is the measure of the resistance of a liquid to spread out. Okay, so let's look back at these. Viscous is the resistance to flow. Surface tension is the resistance to spread out. Okay, so if you look here, it's kind of showing you water molecules on the surface. Okay, so the stronger the intermolecular force, the stronger the surface molecules are pulled down towards the interior of the liquid, and the higher the surface tension. So surface tension means resistance to spread out. Okay, so if a molecule has stronger intermolecular forces, then it's going to have high surface tension. Okay, water has very high surface tension because it has strong intermolecular hydrogen bonding. So the stronger the intermolecular force, the higher the surface tension. Okay, and so this explains why when small objects seem to float on the surface of water, they are just being held up by the surface tension. All right. In the solid state, solids can either be crystalline or amorphous. Okay, crystalline means that they have a regular arrangement of particles, meaning atoms, molecules, or ions with a repeating structure. So I think of these as being very organized. Okay, amorphous means that there's no regular arrangement of its closely packed particles. So we know that solids are closely packed together, rigid molecules, but basically they can be ordered or amorphous, not so ordered. There are 4 types of crystalline solids, and we're just going to look at those real quickly just for you to see them, and then we'll look at what an amorphous solid looks like. All right, an ionic, so here's an ionic solid. You have ions packed together. So we saw this when we talked about ionic bonds, and it's ordered. Okay, here's a molecular solid. Okay, these are composed of molecules, so these are our covalent compounds. Okay, and see it's ordered as well. Okay, network solid has a vast number of atoms. They're covalently bonded together, and then they make a neat arrangement, a neat network as they're named there. And then metals. So a metallic solid is when you have a lattice of just metal cations, and they're just surrounded by a cloud of electrons, okay, that move freely. Okay, but these are all ordered. And then the amorphous solids have no regular arrangement, so they can be formed when liquids cool too quickly, and very large covalent molecules tend to form these because they become folded and intertwined. Examples, rubber, glass, and plastic. So these would have no repeating, organized structure. An example of an amorphous solid I wanted to show real quick is, so here you see that the particles are not ordered and nicely organized as with our crystalline solids, and an example would be cotton candy. So that's kind of a neat example, but others are, rubber, glass, plastic. But I hope this helps with just some terms for the chapter, and I will see you soon.